This video is about how to estimate phase fraction by point counting according to ASTM E562 for quantitative metallographic microstructure assessment for line pipe steels. The idea of ASTM E562 is that you can estimate the volume fraction of a second phase by counting the number of points that fall into that second phase in a 2D cross-section of the microstructure. ASTM E562 can be used with any type of media that gives you a two-dimensional image of a microstructure with a second phase. Sometimes it's used with a light microscope or a scanning electron microscope image or in the scope itself. Test points are superimposed over the image, and then those test points are evaluated whether or not they fall within the phase of interest. Then after enough test points are evaluated, an average is taken to estimate the volume fraction. Samples should be carefully selected so that they are representative of the part for point counting for evaluation of second phase, so that we understand which orientation we are evaluating, and so that gradients or inhomogeneities in the distribution of the second phase are well understood and accounted for or considered properly. There's actually an ASTM standard for guidelines for sample preparation, ASTM E3. We do not want the amount of our phases to be distorted due to the sample preparation, meaning if there's a sample preparation that makes the amount of second phase look more, if it smears or spreads out the amount of second phase, that's going to throw off our second phase fraction calculations. And with that in mind, oftentimes the etchant should be reported. Now for our line pipe steels, the etchant is almost always going to be an etchant called 2% nitol. But we keep in mind that different etchants attack different phases in a different manner. And so some etchants might increase the size of specific phases. And how does that happen? One way is if the etchant makes pits or etches very deeply the second phase, it may gouge out and make that second phase look larger than it should be. So it's suggested that the etching time can be reported. That's not going to be typical for our stainless steels because 2% nitol etching is pretty straightforward. The most appropriate magnification for our application of point counting for determining volume fraction will be a magnification where the second phase constituents are about 1/2 the size of the grid spacing. We're going to count points on our grid that are completely in the dark phase as 1, and points that are only partially in the dark phase as 1/2. Now here's an example with a 5x5 grid for 25 total points to evaluate. And as you do this, you'll get faster and faster. But as I look at point 1, if I start from the top going left to right, I see no dark phase under the point. Here, to me, it appears like the point is half or partially in the dark phase. Then I see no dark phase under that point, none, none, none. Now I see another half. None, 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 none. I see dark phase here under the point. None. Here it looks partially under dark phase. Here again, partial. None, none, none there, none there. None there. Okay, so now I need to add these up. So there's a partial right there, so that's half. Keep going down. Half plus half, that's 1. 1 plus a full one here, that's 2. There's a partial there and a partial there. So 2.5, 3. So I get 3. 3 points in the dark phase. So my phase fraction estimate using this 25-point grid would be 3 out of 25 points. We're going to use a 100-point grid in our standard procedures, and I believe that's a good approach from Table 2, the guidelines from ASTM E562, because for our line pipe steels, the amount of second phase will range widely from about 0% up to 50%. And if we look at the table, we see that if you have an expectation there's going to be greater than 20% second phase, then you can use a grid with fewer points to evaluate. But if you think you'll have a low amount of second phase, to catch those few points of second phase, you need a larger number of points in your grid. Here's a couple examples of the 10 by 10 grids that we can use in our procedures. And as you overlay the 10 by 10 grid over your image, you can adjust the brightness and contrast of your image and the color, brightness, contrast of the grid so that the points are easy to see and evaluate on top of your image. The result of following the procedure for point counting by ASTM E562 is an estimate of the volume fraction of the microstructural constituent of interest. In our case, it's going to be the dark phase. How would we improve the statistical accuracy if desired? One way would be to evaluate more points. We're going to stick with 100 points per image. That pretty much saturates the amount of points that can be evaluated per image. Another way is to employ multiple operators, multiple technicians or evaluators. We're going to use that method, and that's why we want a lot of people trained on how to understand microstructure and how to evaluate microstructure. And then another way is to evaluate multiple fields. And as we develop this program further, we're going to be requesting more fields and set a certain number of images that we want for each of our pipeline features that we want to evaluate. If there's periodicity or abnormal grouping in the microstructure that we're trying to evaluate, then that could defeat our ability to get an accurate evaluation using point counting. One of those types of periodicity in our line pipe steels is called banding. We'll see an example of that in the next slide. The ASTM E562 recommends a couple of different ways to possibly avoid having inaccurate readings due to banding. One is to use a circular grid, but we are going to go ahead and stick with the 10 by 10 grid, and what we're going to do is rotate it so that the grid is at an angle so that it doesn't coincide with the periodicity of the banding. So here we have an example of a banded microstructure. You can see these bands of the dark phase, and the size of the overlay here is almost perfect so that it's coinciding with the size of the bands. So if I evaluate this whole row, almost this entire row, most of this row, some of this row, and almost this entire row, and so on, is going to be in the second phase. That could lead to a misleading and an inaccurate overestimation of the second phase. Here, if I just move my overlay down a little bit, I'm going to have the opposite problem. Now I'm in the light phase, so for this almost entire row, and this row, and this row, and so on, I am going to underestimate the amount of dark phase. So here's the approach to overcoming that periodicity. Now I have rotated my grid so that it does not coincide and crosses at least one or two of each of those bands with each row. So we want to avoid measurement errors. We need to think about what we're doing, think about what we're counting, make sure we are counting second phase. Not all of these images are going to be optimal. There's going to be some oddities. Sometimes the light phase will actually look like the dark phase. So we need to ask questions. We need to make sure we're only counting second phase, the dark phase, Pearlite. Make sure we're not counting etched grain boundaries as second phase. Ask questions, ask a colleague, someone to help check your estimate. And then one way to reduce random error by half is to measure 4 times the original number of fields.